Hey, so hopefully this is an effective method of recording this. Hopefully the acoustics aren't too terrible or anything. I'm going to keep this fairly concise and fairly abstract. We're going to be going through into a much higher resolution on Wednesday, getting a lot more into the nitty-gritty of how Dynamo works. What I've got on the screen right now here is Dynamo Studio, which is the standalone variant of Dynamo. Dynamo also exists as a plugin for Revit. The two pieces of software interoperate pretty flawlessly. Certain Revit-specific commands aren't available in Dynamo Studio, but you can build a script in Dynamo Studio and bring that over to Revit without issue. It's mostly, the Studio variant's nice if you just don't want to take the time to boot up Revit or whatever, or just sort of operating at kind of a conceptual resolution. So we'll just go through the interface here quickly for a little bit. You've, as you'd expect, got your typical top bar with all the usual stuff in it, file, edit, etc. Various things get tucked up here. We'll get into those a little bit more later. On the left-hand side of the screen here is your little library, which takes the place of something like the bar of commands at the top of the Grasshopper viewport. So this is just various different components you can access in here, sort of sorted by category. You can also search it for a specific component, which can be helpful. So it'll give you various things relating to geometry or what have you. There's some other ways of getting those commands as well, which we'll talk about in a second here. The bottom, you've got this bar, which really only houses the automatic little drop down here. This is analogous to in Grasshopper locking your solver. So what that means is this is determining whether or not when I make a change in the script, it will endeavor to reflect that immediately in the viewport, or whether it will wait for me to manually trigger it. So if I change automatic to manual, I have to click run to have changes reflected. So that can be nice if you're doing something that's really like very computationally intensive and you don't want your computer to chug while you're trying to just connect components together or whatever. You can turn it to manual, set all your stuff, and run to see if what you did works. I'll leave it on automatic for the moment, because that should be fine for our purposes. So the main viewport here has sort of two primary layers of data, kind of literally. You've got your script, and behind that your preview of your thing. So the script, you navigate around, scroll wheel, zooming in and out, middle click, moving things. Right click doesn't, right click and drag does nothing. It is composed of components, very much like Grasshopper, that chain together, very much like Grasshopper. There's a few little differences that I'm sure you'll run into. For instance, in Grasshopper, you click and drag. In Dynamo, you click and click. But you're basically dragging components onto this, either summoning components by clicking over here and clicking a thing and it appears in this interface, or the other way of generating components that's quite handy, I find, is you can just right click and that brings up a search field that will give you whatever command you search for. You just go down this list and pick the one you want. So that works pretty nicely. Similar to double clicking in Grasshopper, but just on right click instead. Let's talk about the interface a little more, and then I'll move on to some other stuff you can do with the scripting here. So if you, there's a toggle for this, and I can remember where it is. If you go Control B, that's how I've been doing anyways, this is the hotkey. Press Control B, and your script kind of just gets ghosted in there. And now we're just looking at our preview. Right click and drag tumbles your view of your preview. Middle click pans it. And then one thing that's kind of interesting, it's sort of analogous to Grasshopper in this way. If I click this point here that I've defined parametrically in my script, I get this little gumball on it. And now I can manipulate where that point is. And give it a second, it's a little heavy. The script will eventually update to reflect the change I've made. So that's quite nice because you can set something in as a parameter, and then instead of having to fiddle like 3 little sliders to scoot it around, you can just click and drag the thing once it's in the viewport. So it can be quite an easy way to affect those sorts of changes. So if I go Control B again, we'll hop back over to the command line here, or the command line scripting interface, and talk about a couple little more things and how this script goes together. So one of the things that Dynamo does that's quite interesting in my mind is this little gadget right here. So what this is this is an instance where a particular relationship between these numbers that gets defined as a written expression, and then the module reflects that, the component reflects that. So if I double click, it pulls up this little, your code block goes here. And I imagine most of you won't play around with this too much. I'm also not entirely sure what the syntax of this is. It doesn't seem to be, it must be documented somewhere. There's no way it's not documented somewhere, right? But I haven't found it yet. So, but if you go something like A, let's say we just go like A times B, and we make that click out. What we've got now is we've got a thing where I can hook up a number slider if I want. Oh, sorry, got a grasshopper coming through. Hook up a couple number sliders to this and have the output be the mathematical relationship between these two sliders. So that's a very nice little piece of functionality that differs somewhat from Grasshopper, and I think offers quite a bit of power. To do the same thing in Grasshopper, you'd be probably firing up a little Python module in there. But that's neither here nor there. Let's talk about how this script goes together. So, as you often have in parametric definitions, on the left-hand side we've got sort of the crudest inputs that then get increasingly resolved into my outputs for this, right? So we've got 3 different points by coordinates, so that's just a point that's defined in X, Y, and Z here, and some number sliders that are, don't let your scripts look like this. If you don't have a slider defined and you start manipulating something in the viewport, like scooting around a point and there's no sliders defined to govern that point, it will just kind of fire them in for you and it gets quite dirty. So I'm defining a set of 3 points and then drawing an arc through those 3 points, which is, as you can kind of see, is this curve here, which is pretty straight right now. I'm then doing that again on the other side to make the bottom one. You can see there. And then those are being combined through a sweep. So I've got a profile, I've got a path, they're being swept together, and this, if we just unhide this first actually, you can see there's just a plain surface there. So we just made a surface. We're going through and then we're going to divide that surface into quads, into U increments and V increments, which will yield a grid on the surface, a grid of points on the surface. So if we turn this on, these are the set of points we've got through dividing the surface in this way. This quad point listing command, and this is important to note, is not a default command present in Dynamo, but rather I've gone to packages, search for a package. This takes a second to load up. And this is an interface that will allow me to find and download packages or components that other people have designed and upload it. So it's a bit like going and finding plugins for Grasshopper, except it occurs native inside Dynamo. So got these points. The points are then turned into surfaces by perimeter points. The data structure is already as we want. It comes in as groups of 4, and we need 4 here to get like a 4-sided polygon, right? Then with this module, we're finding a point on the edge of those surfaces, and then, a point in the middle of those surfaces rather, which is just like the center point of the surface. So if I put this back on for a second, you can see a point right in the middle of each. That point is then used to draw a sphere on the surface, and then we're taking the surface, we've thickened it here, made it solid, and then we've Boolean differenced out that sphere, which is how we're getting the holes. At the same time, we're picking a face off of it. We're using this little business here, which is a little awkward. By default, Dynamo thinks of addresses from the bottom up, whereas Grasshopper thinks of it from the top down. So what I mean by this is in Grasshopper, if you say, I want to retrieve the first item in this list, it will give you item 1 of each branch of data in your data tree. In Dynamo, if I say I want the first, it will give me the first branch with all those items. So it's sort of backwards of how Grasshopper thinks about it, which is fine. But what that means is that I've had to take the list and transpose it, flip it. So basically, instead of having let's say 6 trees or 6 branches with 4 items on each branch, I've got 4 branches with 6 items on each branch. So I'm using this to be able to select just the bottom edge of any given one of these geometries, and then that becomes what we rotate that geometry around. That becomes our axis that we rotate it on. Just all this in here is all this is just defining the axis. And then we're setting the rotation using an attractor point, and this is a thing that you can apply in Dynamo, in Grasshopper, just about in anything, as a way to make a quick and dirty attractor point, which is what I've done here. I've got a point by coordinates, which is this point that we've been just playing with a second ago. I then take that point and I draw a line between that point and a point on each piece of this geometry. So if I turn this back on for a second, you can see a whole big blast of lines connecting our attractor point to everything we care about in the wall. Turn this off. I then check the length of each of those lines to tell how close this part is to the attractor point. And so what this means by default is that things that are further away are more affected. That's typically not what you want out of an attractor point. Typically you want an attractor point working the other way around. The closer the thing is to it, the more the impact is. And so that's this little code block here, where all I'm doing is I'm saying we've got number A, our curve length, coming in, go 1 over A, multiply the result by B. So B is just a magnitude. It's just a thing, there's a slider up here. I scooted up here because it goes with the other slider. That just lets us set the intensity of that outcome, and 1 over A gives it an inverse relationship. That means that the length of the bigger A is, the longer the curve is, the less the effect coming out the other side. And then that's used to rotate in this rotate command. Our geometries are plates. They get rotated around our axis that we made, and we get the effect where the fins tilt more the further they are from or the closer they are to the attractor point. The same thing I'm doing with the attractor point with radius here. So I've got the exact same idea. I check the curve length, feed it into this code block, 1 over A times B, set a magnitude for B, and get out the other side holes that change size based on how close they are to the attractor point. Fine and dandy. That brings us to this little thing that's not loading right now. Import instance by geometry. This is a Revit specific Dynamo command. So if I go ahead and open up Revit, which I possibly should have had running beforehand, so hopefully it doesn't take too long, we can take a look at how this can be used inside Revit. So right now it's just cool geometry. We can export it as a SAT file or whatever, play with it, Control B to pop back over, manipulate it, tune it. I can also change these curves if I want. That's all fine and dandy, but it's not really the part where Dynamo gets noticeably more interesting than just doing the same thing in Grasshopper. And that, wow, this is kind of heavy in my poor little laptop. And that point is when we start bringing it in to Revit. I probably should just open the previous one. That would have been easier, but anyways. So inside Revit, tabs at the top, an add-ins tab. Click that, and you'll have a Dynamo button, assuming you've got Dynamo for Revit installed as opposed to just Dynamo Studio. So if I open that, it'll take a second. I might need to kill real Dynamo here. It might be too heavy. You can see the curve changed, which is kind of neat. We'll just save this and make real Dynamo go away. Dynamo comes in. It can, unlike other Revit windows, it can live on its own screen, which is very helpful. And so we'll just open up this little script we were just looking at. Again, eventually. Oh, Dynamo seems to have crashed, so that's not inconsistent with my expectations about, showing computer things. Let's try that whole process again. So in the same way that Matt was talking about in class today, in an environment like Dynamo, even though it's fairly sort of visual and intuitive compared to, like, say, traditional coding, I was about to open this one. Fairly intuitive and visual and whatnot, it's still important to think about things as in like pseudocode terms. Helps a lot when making decisions about doing this sort of thing. So this is the output that the script gives. We're just gonna delete that for now. We'll talk about how we get there in a second. So go add-ins, Dynamo. No, I'm going to click this. I haven't tried this before. My expectation is that this will mean that it won't endeavor to draw it until I try to draw it. So hopefully it loads much quicker. Yeah, that's exactly what happened. So this is where a manual run comes in really handy with Revit, where if you've got a thing that's like dumping geometry into Revit every time you run it, that gets really super heavy in a hurry. So I'm gonna make the library go away, just so we got a little more room to look at here. We're gonna go through our script. It hasn't run yet. So everything's still the same as it was before, same interface, all that, except now we're directly plugged into Revit, which means I have access to this command here, and other Revit-related commands, like you can make walls, you can make floors right out of Dynamo, which can be very cool. So let's try running this, and we'll see if my computer will take it. And with any luck, we'll see a result. There we go. So, as you can see, the geometry is populated in here in the viewport, and technically I can still make all the same manipulations I was before. I'm not going to because it's, you guys don't need to look at my computer failing to load things. But anything I was doing before I can still do here, and it will be reflected over here, where it's gotten dumped into Revit. So I'm just going to hide the Dynamo window for a second, and here's what's going on as a result of that in Revit. So you can see that this object has come in as, I think these are technically masses right now, or something. But they've come in and are now a thing that I can start to begin to operate on using your sort of expected Revit behaviors. The real power of it, I think, in my mind anyways, comes from when you start, instead of dumping things over as masses and as sort of raw geometries, to start being able to make decisions, say things like, for instance, to dump things over as walls, can be very cool, extremely powerful. But anyways, I think that's enough of a little taste of how how Dynamo works, what Dynamo is, and I think we'll be making available some sample scripts to you guys. I'll whip some up here in the next couple days that are sort of useful for picking apart and playing with. And then I believe we'll also be going over building something like this this script we were looking at, building something like this, sort of more or less step by step in class on Wednesday. Probably not quite this big, but something along those lines we'll go through fairly precisely. But yeah, best of luck.